Alright, so this is writing the equation of the parabola. This is going to be problem 3, which says it has a focus at 0, -3. Directrix is going to be y equals 3. So again, first suggestion is that you draw it. So I go to 0, -3, which means I'm down here. This is the focus. The directrix this time is y equals 3. So already I know that my parabola has to open down because it has to contain the focus, and the focus is down here in relation to the directrix. So from here I'm going to sort of ask myself, where's the vertex? Well, it's in the middle of these two. So the middle would be right here on 0, 0. So that's the vertex. And remember I said the parabola has to contain the focus, so it's going to look something like that. Okay, so to set up the equation, we're going to start by doing, you sort of can pretend there's some point. Pretend it's called xy. It doesn't matter where. It can be anywhere on the parabola. And the first thing you need to do is find the distance between it and the focus. So you're going to set up the distance formula. So you've got x minus this from the focus squared plus y minus -3. And you might be saying, why did she write minus and negative? It's just plus. I know, but you need to make sure you remember that the formula is always minus. So I don't want to, change it in that first time I write it. All right, on the other side, you're going to be asking yourself, how far away is this point from the directrix? So in this case, again, what you do is you just put, essentially this, sort of change it to a minus. That's not really the technical idea, but that'll get you the right thing every time. So you're asking yourself, what's the distance between here and here? And in order to find that, you're going to subtract the y value from the directrix to find the height. Alright, so like we said, we need to square both sides. When I square this side, the square root cancels. I'm going to get x minus 0 squared. Well, x minus 0 is just x, so I've got x squared. Okay, this one is going to be y plus 3 squared. Minus negative is plus. This one's going to be y minus 3 squared. Okay, now's a great time. Pause the video, write these out twice, and FOIL them. You can do that. And again, some students will skip this step because they already see the pattern for always squaring, and that's fine. In the future examples, I might do that as well. Okay, combine your like terms. Okay, this is the only side with an x squared, so I'm going to move all the y's over. So I'm going to minus y squared, and I'm going to minus 6y. I'm going to minus y squared, and I'm going to minus 6y. And you might say to me, wait, every time those y squareds are canceling? And yes, you're right. All parabolas have either x squared or y squared. They will never have both in the final equation. Okay? So those cancel, but these do not cancel, so be careful what your math is doing. So x squared plus 9 is equal to -12y plus 9. And then we're going to minus 9 from both sides. So I get x squared equals -12y. And then just divide by -12. So the final answer is just y equals x squared over 12, negative x squared over 12. And you might say, wait, the negative, how to get up on top? It doesn't matter. It's negative. It has one negative. It's either on the top, in the middle, or the bottom, but one negative, okay, to make the whole thing negative. Now, I know this is good because remember, anytime you have y equals and then you have a negative as your x squared, that means your parabola opens down. This negative tells you it opens down. So go back to our picture, it opens down. So that means that we're on the right track.